Hi everyone, welcome to my video report of Lab 2 in Physics 2 class at Georgia Tech. In this lab, we basically do the same experiment as what we have done in Lab 1. In Lab 1, we prepare two U-tapes with the same charge, and then we hover one U-tape over another U-tape. And we see the tape on the top, which we name tape B, close above the tape on the bottom, which we want to call tape A. Then we compute the charge on those tapes based on some measurements. In Lab 1 setup, we made two important assumptions for simplification. The first is that the two U-tapes have the same net charge. The second is that we assume all charges on one tape is located at the center of the U-tape. With these assumptions, we transform the problem into a model with two-point charges with gravitational forces. In this lab, we relax some of the constraints, and we now assume the charge is evenly distributed across the length of the tape. In other words, each tape is a line charge now. For simplification, we convert each line charge into 10 uniform point charges, and we will take the sum of electric field or electric force components as the total quantity for the entire tape. Down below is the link to my code implementation of the model. Feel free to have a look at it and follow along my explanation. We will explain the model bottom up. Firstly, we want to examine the electric field of tape A at each individual point charge of tape B. Here are some symbols that we use to denote the point charge of tape A, which is dQA, and point charge in tape B, which is dQB. For each dQB, or a red sphere here, we sum up the electric field created by each of those blue spheres at the location of this red sphere. For each pair, we use this formula to compute the magnitude as well as the direction of the electric field. Now we have the electric field created by tape A at the location of each point charge in tape B, and those electric fields are shown in green arrows in the diagram. We denote these as dE. Next, using the formula below, we can compute the electric force on each point charge of tape B exerted by tape A, and we name this result dF. Then we can sum up all dF across all point charges on tape B, and we can get the total electric force on tape B by tape A. In this lab, we have the same observation that the momentum of tape B is not changing. Hence, by Newton's second law, tape B is in equilibrium. In other words, the net force on tape B is zero in the vertical direction. Now we want to find the main vertical forces on floating tape B, and there are two. One is the gravitational force, which is represented by the yellow arrow, and the other one is the electric force on tape B by tape A, which is shown as the white arrow in the diagram. These forces are in opposite directions but have the same magnitude. Now we are able to build our model and construct the identities from our previous explanation. In trials, we want to adjust the values of charge in tape B to find the correct number that makes the system balanced. I start from the estimated result of Lab 1, and the final result is about 1.548 times 10 to the negative 8 coulombs. For the first additional question, we can clearly see the difference between results from the two labs, and the result from the second lab is approximately 2.86 times of the result from Lab 1. The major reason of the difference should be that the approximation models are different. That is, in Lab 1, we use point charge to approximate the tapes, and in Lab 2, we use line charge. In point charge model, all charges are located at the center. Hence, the distance between any two charged components is simply the vertical separation distance between two tapes. However, in the model of line charge, all charges are distributed across a line. The distance between two charged components contains not only the vertical component, but also a horizontal component, and this results in a larger distance compared with the one in Lab 1. So in intuition, the tapes would need greater amount of charge to generate a larger electric force for repelling and balance out the gravitational force. A line charge should be closer to the real value because it makes less assumption approximation to the model. So the error or differences from the reality should be smaller. Thank you.